Lesson 9.3, using quadratic formula to solve equations. Let's look at example B. We first start with 2x equals x squared minus 4. In order to use the quadratic formula and find the discriminant, we need to find our a, b, and c values. We can only do that when it's written in standard form. So take 2x equals x squared minus 4 and move all the terms to the same side. So we're going to subtract the 2x and put it in the correct order. So we get 0 equals x squared is the first term, minus 2x is the second term, and then the minus 4. So now we can correctly name our a, b, and c once all the terms are on the same side. So we have a as a 1, b is negative 2, and c is negative 4. If you would like to go ahead and plug everything into the quadratic formula, feel free to do so. Many students do better if they just start with the discriminant, b squared minus 4ac. So b is negative 2, use parentheses when squaring a negative, minus 4 times a, which is 1, times c. And c is negative 4. Evaluate the discriminant. We get negative 2 squared minus 4 times 1 times negative 4. That equals 20. Because that's a positive value, we should find that we get 2 solutions when we solve this problem. Let's do that work now. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You will do best, especially when the b is negative, if you actually make it negative 1b. So we have negative 1 times our b is negative 2 plus or minus. You could reevaluate the b squared minus 4ac, but you already found that it is 20. So some students may just want to write in a 20 here. I'll go ahead and plug it in since we have the space to do so. All over 2a, so our a is 1. Be sure to extend that fraction bar all the way across, because the whole entire numerator is divided by the 2 times 1. So simplify each part. Negative times negative is a positive, so we get 2 plus or minus. We already evaluated the discriminant, the b squared minus 4ac is 20. And all of that, so extend your fraction bar all the way across, all of that is divided by 2 times 1, which is 2. Let's simplify the square root of 20. It is not a perfect square, but it can be simplified by doing your prime factorization. I start with dividing by 2. You can divide by any prime number. You should find 2, 2, and 5 as your prime factors. So here we have 2 times 2 times 5 as our prime factors of 20. We have a pair of 2's. That pair of 2's comes out of the radical sign. And we have the square root of 5 left for that part of our problem. Notice how everything else has just followed along throughout our answer. We brought down the 2 plus or minus and the divided by 2. All of that is part of this step, 2 plus or minus and the whole divided by 2. We were only simplifying the square root of 20, so that became 2 to the square root of 5. One thing you can notice at this step is that everything is divisible by 2. One thing you can notice here is that everything is divisible by 2. 2 is divisible by 2, 2 divisible by 2, and this 2 is divisible by 2. So you can reduce to get your simplified answer. That is the simplified answer, and as far as we need to go. We will not use approximate solution, so you will not need a decimal value. Our x's from least to greatest will be 1 minus the square root of 5 and 1 plus the square root of 5. Write your answers in set notation.